Now we are good to go to the problem sets. And let's do this quickly for 5 minutes. Question 3, find the reference angle for 241 degrees. So all we need to do is to set up the coordinate axis. That's it. And 241 degrees is in between your second and third angle. I mean, second and what am I trying to say? I mean, it's in the third quadrant, okay? So our angle is here on the third quadrant, okay? And sketching it, so it gives us this line ray, and this is of course our theta. This whole thing is our theta, okay? This is our theta ref. So what is our theta ref? Our reference angle, theta ref, is just equal to 270 degrees minus 241 degrees. And that's equal to 29 degrees, right? That's our reference angle, 29 degrees. Okay, number 4. Question number 4. Name these Greek letters. A. So the first is A, and A is also called alpha. The second letter is beta. The third is gamma. And the last is phi. So this symbol is phi. Okay, so these are the Greek letters. Now let's go to the problem set, the real problem set. For problems 1 to 6, sketch the angle in standard position in a UV coordinate system. And then mark and find the measure of the reference angle. Find the sine or cosine of the angle and its reference angle. Explain the relationship between them. We just need to choose from these numbers. So I'm going to choose this and 5 and maybe 4. No, let's have one sine. Okay, so I'll take sine of 120. So let's do number 1. Or the first question, number 3. Okay, we have cosine of 140 degrees. Cosine of 140 degrees is on the second quadrant, right? So it's here. And this will be your theta. Okay, and this will be your reference angle. So this is theta ref. Theta ref here theta ref is equal to 180 minus 140. So that would be 40 degrees. Okay, so our theta ref is 40 degrees. And what is my cosine of 140 degrees? So let me see. Cosine of 140 degrees would be negative because it's on the second quadrant. And on the second quadrant, you have negative cosine and positive sine, right? So cosine of 140 degrees will give me negative 0.7660. While my cosine of the reference angle, cosine of 40 degrees, will always be positive because it's an acute angle. Okay? So the answer for cosine 40 is the cosine of 40. They must have the same magnitude. So 0 point, this is negative. this will be negative of 0.7660, but this one, the cosine of 40 degrees, is 0.7660. They have the same magnitude, but they have different signs. So how about number 4? Let's go to number 4. I mean number 5. So cosine of 300 degrees. What is cosine of 300 degrees? So in essence, this is on the fourth quadrant, right? So this is here. And of course, this would be our reference angle, theta ref, and this would be the theta. So my theta ref here would be equal to 360 minus 300. So 360 minus 300 is just 60 degrees. Okay? This is my theta ref. So what is my cosine of 300 degrees? So cosine of 300 degrees is equal to, let us put it here, so we will have a place for the decimals. In case 300 degrees will be equal to cosine of 300, that's 1/2 or 0.5. And we are on quadrant 4, remember. So we have positive cosine, negative sine. So what is my cosine of 60 degrees? Well, we might be surprised they will have the same value. So cosine of 60 is equal to 0.5 also. They have the same value. Okay, so both are positive. For number 6, so number 6, we have sine of 120 degrees. So what is sine of 120 degrees? It is on the second quadrant because it's in between 90 and 180 degrees. So this is my theta, and this will be my theta ref. So what is my theta ref? My theta ref here is equal to 180 minus 120, that would be 60 degrees. It's my theta ref, theta ref, theta ref. Okay, so what is my sine of 120 degrees? Because we are on quadrant 2, so we expect our cosine to be negative and our sine to be positive. So sine 120, that would be, sine 120 is equal to square root of 3 over 2. Or in decimal form, that's equal to 0.8660. Note that this is positive. Okay? How about my sine of 60? So what is my sine of 60? Sine of 60 degrees, they should have the same magnitude. So sine 60 is the same. You have 0.8660. So remember that all of the sines or cosines of our reference angles are positive. And you have to take note also where the angle is located. Is it located in quadrant 1 where cosine and sine are positive? Is it located in quadrant 2 where your sine is positive, your cosine is negative? Or in quadrant 3 where both cosine and sine are negative? And or quadrant 4 where your cosine is positive and your sine is negative. So those are the things that you have to remember. Let's box the important details. These are the important details here. And this also. Okay, so I don't need to box the middle one, or I'll box it with a, you know, uh, okay, that's better. So these are the answers for this problem sets. For problem 7 to 14, use the definition of sine and cosine to write sine theta and cosine theta for angles whose terminal side contains the given point. So let's just choose. Let's choose 7, 10, and maybe 11. So let's start with 7, and let's create a certain square for that. So let's create a box for each of the items. So we have this for number 7. So we start with, of course, the sketching, where we would find the point. So the terminal side contains the point 711, meaning it's on first quadrant, right? So if we're going to sketch the graph of this would be something like this. And of course, we can define this right triangle in there. And all we need to do is to, okay, it doesn't work. So I think we have to write some, okay, it's a triangle in here, and write a triangle. So here, like that. It doesn't work again. So, okay, anyway, that would be the angle. So we have a right triangle in there, and our theta is here. This is our V, this is our U, this is our R. And our point is here. This is the point on the terminal side, which is equal to 711. So 711. So what is the definition for the sine angle? Sine theta is equal to u over r. Am I correct? Or v over r? It's v over r. It's opposite of the angle over the uh, the hypotenuse. Our hypotenuse is r. Cosine theta is equal to u over r. But we don't have our r. We have v, which is 11. Our u is 7, but we don't have r. So we have to compute for r. And we are going to use the Pythagorean formula. So a squared plus b squared is equal to c squared. In this case, u squared plus v squared is equal to r squared. So r squared is equal to 11 squared plus 7 squared. So r squared is 121 plus 49. So r squared is equal to 170, right? So r is equal to square root of 170. So what is our sine theta? Our sine theta, so let's take sine theta first, is equal to v over r, and our v is 11, over r is square root of 170. Okay, so that would be, our sine theta would be 11 over square root of 170. That will give us 0.8436. Okay, so this is our sine of theta. Okay, what about our cosine of theta? So let's solve for the cosine of theta. So b cosine of theta is equal to u over r. So cosine of theta would be, our u is 7 over square root of 170. So cosine of theta would be equal to, let's just replace our 11 at the top with 7. That would give us 0.5368. So this is our cosine of theta. Okay, this is our cosine of theta. I think that's too dark, so let's use this. Okay, so are we correct with the signs? Look that it is in quadrant 1, meaning that both your sine and cosine are positive. So our cosine is positive, our sine is also positive. So now we got the sine and cosine of the theta. Now let's do number 10. We need a square. Let's use this. Okay, so our number 10 seems to be in quadrant. What quadrant is this? This is in quadrant 2, right? So number 10 is in quadrant 2. So we're going to have this sketch. So this is our sketch. This is our point. And where is our theta? Our theta is here. Okay, so this is quadrant 2, meaning our cosine is negative, our sine is positive. Okay, so drawing, let's take it out first. So we have negative and positive. So we would like to draw a triangle here. And then we are to draw also this square, because this is a right triangle. Okay, this point is point -6, 9. So our v here, our u first is 6, our v is 9. So our r, this is our r, this is our v, this is our u. Okay, so r is just the square root of 6 squared plus 9 squared, right? So r is equal to the square root of 6 squared plus 9 squared. That would be 3 square root of 13. Okay, so that's 3 square root of 13. That's our r. So if that's our r, this is our r. Okay, so how do we find our sine theta? So our sine theta is positive, because it's positive here for our sine. So that would be positive v over r So that's 9 over, that would be 9. Okay, my 9 is really ugly. I'm sorry. So 9 over 3 squared of 13. So our sine theta is 9 divided by 3 over square root of 13. So that's approximately 0.8320. Okay, this is our sine theta. And it's positive because it is in quadrant 1. What about my cosine of theta? My cosine of theta should be negative because it's in quadrant 2. Did I say quadrant 1 a while ago? It's in quadrant 2. Okay, we have u over r. So u over r, our u here is 6, over our r is 3 square root of 13. So that would be, what is that? That would be 6 divided by 3 square root of 13, but it's negative because it's on the second quadrant. So this is negative. So negative 6 divided by 3 square root of 13, that would be 2 square root of 13 over 13, or negative 5 point, or negative 0 point, negative 0.5547. So this is negative 0.5547. Okay, that's our cosine of theta. And it's negative because it's in quadrant 2, right? So this is the answer for number 10. What about number 11? So let's do number 11. Okay. Our number 11 is 4 negative 8, which means that it is in quadrant 4. So for number 11, we are going to get a sketch, and this sketch is okay. Let me have this. So it's in quadrant number 4. So this would be like that, and like this. Okay, so like that. Okay? Okay. And we have a right triangle here. So that's it. And we also have this. So our point is here, and this point is equal to 4 negative 8. This is 4 negative 8. This is on the fourth quadrant. So because it's in the fourth quadrant, we would expect our cosine to be positive and our sine to be negative. Okay, now let's begin. So what is our u here? This is our u, this is our v, this is our r. And our u here is just the x coordinate. So u is 4, v is negative 8, and r is just the square root of, we could actually take out the negative for the v. The negative is it's essential in predicting what the value of cosine or sine is. So it will depend on the quadrant wherein the point is. Okay, so our r here is equal to the square root of 4 square plus 8 square. So our r is the square root of, what is the square root of 4 square plus 8 square? That would be 4 square root of 5. Okay, this is our r. I need the lighter one. Okay, this. So we have our r now. All we need to do is to solve for the sine theta. And sine theta should be negative because it's in quadrant 4. So negative of v, so it's v over r. So this would be negative 8 over our r, which is 4 square root of 5. So our sine theta is equal to 8 divided by 4 square root of 5. So that's 8 divided by 4 square root of 5. So that's equal to 0. So it's negative 8944. Okay? So this would be the sine theta. What about our cosine of theta? So let's solve for cosine of theta. Cosine theta is u over r. And cosine is positive because it's on the fourth quadrant, so it's positive. So we have 4 over 4 square root of 5. And cosine theta then would be equal to 4 divided by, so we just replace our 8 with 4, divided by 4 square root of 5. That would be square root of 5 over 5, or 0. 0.4472. This is our cosine of theta. Okay, so these are all our solution for problems 7 to 14 with definite numbers 7, 10, and 11. So for tomorrow's lecture and videos, we're still going to do some problems for this lesson, which is lesson uh, 3, for chapter 5, lesson 3, and moving along to 5-4 up to the last lesson maybe. So once again, thank you for watching and listening, and I hope you are enlightened with the cosine and sine functions and the techniques on how to solve them using the point and the terminal side. And again, have a nice day, everyone.